Let's take a look this time at the EaganMatrix output section, the master section. This is composed of the outlined box on the matrix here in association with the gain dial that controls the master output, and also the recirculator dial and convolution response and recirculator control panels. Those all are involved. Now, anyone who's programmed the matrix has used the output section, because without it you can't get any sound out. So everyone's had some exposure to this who's done anything with the matrix, but you might not understand what's going on with these other options, and there are a number of fine points in dealing with the convolution responses and the recirculator controls that are not even in the manual. I've been emailing Ed and Lippold on a number of things, and there's some information I'll present here that you won't find in the manual. So let's dig into this a little deeper. Let's go through the output section control flow. It starts with the SLSR columns. If you set something there, that will be input into the output section, where all voices will be sent first to a saturation wave shaper. This can create overload processing that triggers typically when the output is greater than unity, greater than 1. There's also a soft clip limit function that can be set through an ancillary function when you select the multiply add matrix column limiter options. That gets sent into the pre-recirculation convolution. This is a set of impulses that are meant to imitate responses from objects that have been recorded: waterphone, waterphone 2, autoharp 2, guitar, snap, wood, metal, and fiber. These are set in the convolution panel where you have certain options that we'll talk about. Note that this doesn't mean if you select wood or guitar it's going to sound like that. These are impulses that are indicative of that, and we'll see how those work later. From the pre-recirculation convolution, we have the option to set an interpolation between up to 4 of these types that you select, and you also can select a wet-dry mix of convolution to non-convolution. That gets sent into the recirculator, the reverb echo processor. There you have the option to select a number of different echo and reverb types: digital reverb, modulated delay, swept echo, analog echo, digital echo with low-pass filter, and digital echo with high-pass filter. There are 2 columns available to program this, and what those are meant to do is allow you to select one of the 4 parameters that are associated with the recirculator. Those parameters change based on which type of echo or delay you select. The second column also allows you to program the general mix of the recirculator. The output of the recirculator goes into the post-recirculation convolution. This is identical in design to the pre-recirculator convolution, and you can select one or the other or both, though by far it's more common to use the pre-recirculator convolution. Output from that gets sent into the submix. Here you can route that back into the matrix for further processing, or you can use the output of that goes direct to the master mix. Here you also have the option to program the LR column, which is an unprocessed input, and there's an M mix option that allows you to select the percentage of processed SLSR to unprocessed LR. So you can make very subtle combinations of processed and unprocessed sounds. The gain dial can be used to manually set the output, or that can be done through programming in the matrix itself. The outputs then just go to the AES or audio outputs. In addition, there's a recirculator control dial that you can manually set your output of the recirculator if you don't want to program it in the matrix. So now let's take a look at how these are actually used. And we'll concentrate on the recirculator for this video. Let's start by bringing up the building block stereo noise preset. I've set this so that the recirculator mix is minimum. I also have turned off all of the digital reverb settings we'll talk about, and it sounds like this. Just some noise. There's no reverb on it yet. It's a very simple program where Ed uses 2 oscillators that are outputting noise in the SLSR columns. There's a little different formula for A and B, and you can see he set these in the blend function using the first barrel so that he can create a stereo width change, but we're not really going to be too concerned about that here. And he's used a multiplier, very small number, on this SLSR noise because that's a full spectrum sound and it will saturate everything and possibly overload. In this case, we don't have any of the output section column set other than the SLSR. So we know from previous discussion, this will get sent through the recirculator and then to the outputs. Let's bring up the recirculator, and we're going to use the default digital reverb setting. I set this so that the recirculator mix, and this will control the overall wet-dry amount of the recirculator that I can set if I use the column settings, but I'm not using them here, so we'll just control the recirculator through the recirculator mix dial and through our recirculator dial settings. Now let's look at the digital reverb parameters. Number one, there's a diffuse parameter. Ed says this is very subtle. It interacts with decay time. The parameter was left in because depending upon decay time, different diffuse times can make the decay sound smoother or, if wanted, more metallic. It's a subtle effect. It helps to fine-tune the reverb sound to try to get maximum quality out of the limited RAM resources available to the recirculator. Now the second parameter is darkness. This applies a high-frequency roll-off to the input into the recirculator, and the sound is duller immediately. Damping reduces the high-frequency content with each feedback loop into the recirculator. The sound is duller over time, and you can fully damp it out so that you won't really even hear any reverb. And then you have your decay, the amount of decay and reverb you're actually applying. So let's listen to what these sound like when we bring them in. I've set the recirculator to the max setting because I want to hear the diffuse, darkness, damping, and decay parameters as much as possible, but I've set all of them to 0 initially. And what I'll do now is connect up my Kenton controller so I can control the dials, and we want to look at the spectrum analyzer to see what's going on. So here's our base noise. You can see a flat line, full spectrum noise going on there. Let's look at the diffuse parameter first. Here's without diffuse. And I'll turn that completely up now. Here's with diffuse. You can hear the initial attack is diffused. It's not quite as sharp as when I turn it off. With, and here's without. You can hear that when we listen to noise. Let's turn that down. Now let's listen to what happens when I turn up the darkness parameter. I'll keep my finger down and you'll easily see the filtering of noise that happens here. You can see that roll off, it's quite noticeable. I'll bring it out now. Okay, let's turn up darkness and diffusion to the max. There, now I have a kind of diffuse dark sound, and you can really hear the difference between that and when I turn them both off. What I've done here is I've taken the darkness parameter, only that. I've turned down all the other parameters and just turned up darkness with the recirculator set to full so I get the full amount. And I've compared that to noise with the single pole low pass filter. You can see they're quite similar. The single pole filter has a steeper slope perhaps, and maybe that's one thing we can use darkness for, as a kind of single pole filter substitute with a lesser slope. We'll have to experiment with that. Now let's listen to what happens when I bring the damping up. What I'll do first is turn the delay on to max. Alright, so here's with maximum delay. Let's bring the damping up a little bit at a time as I play. It almost takes the decay all the way off as I damp it fully. I'll bring it out now. So that's all quite noticeable, all four of those parameters. One other setting that we can use, and that's the extend option. Here's what Lippold and Ed have to say about extend. Extend runs the filter at a lower sample rate. It can double the effective max delay time. This means the wet part of the signal contains only lower frequencies below half sample rate, and you have to mix in dry to get more highs. In many cases, this sounds pretty natural. There are many reverb effects which don't do much with highs and work well with extend. Let's turn off extend and look at our spectrum. Let's turn on extend now. You can hear it goes on a little longer, and you can definitely hear the high frequency content being cut out. Let's look at the second recirculator option, the modulated delay. This allows you to set depth and rate parameters, which are very subtle, in addition to feedback and time parameters, which are quite obvious. Lippold and Ed have this to say: depth and rate controls are kept to a minimum to avoid feedback issues within the algorithm. It can sound really nice now, creating a very smooth reverb-like sound at the expense of obvious early reflections and a pitch tail in the echoes that sweeps a bit. What we'll do here is change the noise program a bit. What I've done is used a volume multiplier that uses a shape generator set to a single cycle with a very fast ramp down. So this is going to give me just a noise ramp. When I turn off the recirculator completely, you can hear it comes out more. If I turn on full recirculator and I don't have any settings, it's still going to affect the sound a little bit. Now, let me turn the time parameter up to max with the recirculator setting set to max. You can hear what's going on just that single pulse. It's just repeating it in that delay buffer. Now as I bring up the feedback, you're going to hear the delay really kick in. You can hear that tail. Now when I bring up rate and depth, it's not that easy to hear on this preset. Let's bring up another one I created. This one uses a kind of chime-like sound. I can get all kind of metallic sounds out of this. Here is with the full feedback and time, but with depth and rate removed. You can hear that sounds pretty nice. If I take everything off, you'll just hear the dry. And let me bring back the time and feedback. Now listen carefully to the end of this delay. You can hear it reverberate. Now listen to what happens when I bring up the rate and the depth. It really has a marked effect on the tail of the sound. Without. And let me just bring up some of it, because most of the presets do not set this stuff to the full values. You get the idea. It's very subtle. you can hear that it does affect the tail considerably when it's to its max. Almost has a pitch shifting like quality to it. With everything up to full. And let's put extend on it, see what that does. That really changes it considerably. Remember, that changes the sample rate and quite a different effect. So depending upon your preset, extend may or may not give you the sound that you want. Same thing with the modulated delay. It's a lot easier to see what the depth and rate parameters in the modulation section of the modulated delay are doing if we use a sawtooth wave. The same thing will apply to the swept echo that we'll look at the next video. We'll turn the recirculator down. I've created a sawtooth program with a wave bank set to a saw. I send a little bit of that out because I'm going to gate it, and I set it to a fixed frequency. And there's my expected sawtooth wave, all the harmonics present in descending order. Now let's turn the recirculator all the way up. I have all the delay parameters set to 0, but that is still going to affect the sound. You can see it's already imposed a certain kind of a wave shape on this. Now I'll start playing with the depth and rate dials. I can do that with my Haken controller and see what happens. There's our bass sound. I'll turn up the depth. And now I'll turn the rate. You can see a modulation imposed on that. That gets faster as I turn the rate up. And as I turn depth down, that modulation will become less noticeable. That lets you easily see what the depth and rate are doing. So you really have to play around with the modulated delay. Don't set the rate and the depth too high. It's used all the time to great effect. And when you want a subtle reverberation, I think the modulated delay often works very well. Now let's look at this swept echo, the next option. I've turned my recirculator dial to the max and turned everything off. Let's listen to what happens when I bring the time parameter up here. We have depth, rate, feedback, and time. So similar parameters to what we used last time, only now we're going to have an echo. I programmed this little metallic sound. Let's bring time up. You can hear the little repetitions are getting farther and farther apart. So it's really just acting kind of like a delay here, getting slower as I move the dial to the right. Let's bring the feedback up, and that will then bring in my echo. At halfway point, it's considerably longer now. Let's go to 3/4. It's almost getting to the point where it's going to go on forever. If I bring it to the max, it'll go on a long, long time. Now, let's see what happens when I change the rate and the depth when I have an echo going on. We'll set it so that it... And of course, if I play multiple things on the fingerboard, I'll start echoing all kinds of things together to get a wonderful sound. Let's let that all die away, and we'll just play one echo. Alright, now let's bring up the rate and depth. There, you can really hear those are really affecting the sound. Bring rate down. You can hear it's oscillating. And when I bring them both down, I'll just get my echo going. So that one's pretty obvious. Let's see what happens when we extend that. We got to be careful. Sometimes when we extend things, we can get into trouble. Let's not do a full echo. Let's just put a little bit of everything on and maybe put the time down a bit. All right, now we'll extend that. It does extend it, but in this case, it's actually slowing it down. You can experiment with extend. It'll create different effects based on the recirculator type. Let's look at the analog echo next. This one has a few different parameters: noise, offset, and then feedback and time. And here's what Ed and Lippold have to say. For noise, the noise is being added into the recirculating data. And for offset, a reverb timing offset between left and right channel. Left channel time is the same as left channel time if offset is 0, but is less when offset is increased. This effect is not a linear time scale, but can be noticeable, useful in some situations. Okay, let's turn on our recirculator to full, and there's our sound. You can hear with everything at min, it's already kind of muted in relationship to the previous sound. I'll turn up feedback, and now I'll turn up noise, and you can hear that noise coming in. Now I have to be careful with this one. If I put feedback up too much and I bring noise in with the recirculator set to full, I can get some really big overloads going on. So let's turn up a little bit of feedback and some noise. And you can kind of hear that noise. As I bring up the feedback, that noise becomes much more noticeable. Right. Now, you probably won't be using that much of it. It's just something that you want to maybe have subtly in the background. All right, let's bring up our time on our sound. This is similar to before. And let's bring up a little more feedback. It's a much greater, bigger kind of an echo. And slower. Let's bring up that offset now. You can hear, when you turn a dial, you can hear a little bit of noise in the background as it turns. That's not the effect we're really listening for. Let's turn offset up. Obviously, as that changes, the differences between those two channels, it has the effect of making my delay faster. And of course I can turn the time down. And that will make it faster still. And of course, if I turn the feedback up, my echo will increase. I don't want to get too much feedback. Already you can start hearing I'm on the edge now of going to a place I don't want to go. So we have to be very careful with that feedback. An interesting echo, maybe a little bit more difficult to use than the other one. Let's see what happens when we extend this. Again, we get that sample rate change that slows down, but extends it. Now, of course, with an echo, I can extend normally through feedback, so the need for the extend button maybe is not as great as on some of the other recirculator options. Well, we've gone on longer than I wanted to, but let's quick end with the digital echo with low pass filter and high pass filter. This one has similar offset feedback and time parameters that work like the last recirculator we looked at. And let's bring back our noise, where we'll be able to see how that functions. I've set a sound. So there's a digital echo type with a certain offset feedback and time that I want. Now, let me bring the low pass filter down to 0. I'll control that with the Kenton now, and let's see what happens in our noise as I bring up the low pass filter. Nothing when it's off. You can start to hear now some rumbling coming in as I basically bring up the cutoff. Almost a very distant drumming sound as I'm about halfway now. And now it becomes obvious as I bring that cutoff up higher. That's an interesting recirculator type. Let's quickly change that to the digital echo with high pass. We'll get a sound we like. Okay, and now let's do the same thing. We'll take the high pass filter down to min, and we'll bring that up to max. We can really hear that cutoff where I'm taking the lows out now. Just bringing in the highs until they get cut out completely at max of the high pass filter, which is opposite of what happened with the low pass filter. So that's it. Next video we'll actually start talking about how to program the output section and talk about convolution.